So one of the compounds or substances, actually is a better word, that we learn about this year are our metals. So we've got our metals, our ionic compounds, our molecules, and our covalent networks. We're going to focus on metals for this one. There are a few things you have to be able to do or understand about metals. One is you have to name the particles that metals are made up of. You need to be able to name the type of bonds that are between the particles. You need to be able to do a diagram. You have to be able to draw it in an assessment. So something like what I've got drawn on the board there. You need to be able to describe that bond type, so not just name it, but say its nature. And then the last bit is linking its structure to its properties. This video is going to be about the first 4 only. This last one will be a video on its own. So, the particles in a metal are atoms, but those atoms have been arranged in a certain way. What we've got is every atom has lost its valence electrons into the structure. So these negatives are representing valence electrons, the electrons that these atoms have lost, and they're actually sharing those electrons with all of the other atoms. So you've got what we call a sea of valence electrons, because they don't stay put, they move around everywhere. They don't just stick with the atom they came from, they are shared amongst them all. Then, if those atoms have lost electrons, they must have become cations or positive ions. And this is what gives the structure, the solid nature as it were, of the metal. So you've got cations in a sea of valence electrons. So if you were given a table to say identify the particles, you can either say atoms, or you could be more precise and say that those atoms are cations in a sea of valence electrons. So that's our first one, naming the particles, either atoms or cations in a sea of valence electrons. This is better because it explains the properties better, which we'll see later. The relationship between each cation and that sea of valence electrons around them is called the metallic bond. So the relationship isn't between cation and cation. They would actually repel each other because they're both positive. The relationship is between the cation and the sea of valence electrons around it. And this is what the metallic bond is. And because it's positive to negative, it is strong. Anything that's an electric attraction, plus and minus, is a strong attraction. So we see that with ionic compounds as well. They've got very strong attractions because they're pluses and minuses. But in this case, they're called non-directional. So it's not like a rope being pulled. It's actually like being held in place by a force field sort of thing. So if you can imagine the electrons are creating like a force field or a gravity field, if you want to think of it like that, holding those cations in place, then that is a nice analogy or model to imagine what's going on there. What it means is this can move around just like we can move around on Earth, but it's hard for us to get off Earth. The last thing that we're going to be doing, so this is our particles, our bond type is our metallic bond. Drawing the structure, we need to be able to draw this, and our last thing is to describe it, and that is saying that it is strong and non-directional. And that is what our metals are. We're in the next video going to link it to these 4 properties.